let's look at number patterns. Just as we can have patterns like in our flag with the stripes, red, white, red, white, red, white, we can have patterns with numbers too. Let's say you are asked to do a pattern. Well, before we do that, I'm getting a little bit ahead of myself. There are a couple terms I want to look at. A pattern is a set of numbers or shapes that are in a certain order. Now, you might have heard the word sequence before, like if you're retelling a story or if you're writing a story. You have a sequence. You have a beginning, you have a middle, and you have an end. Well, we have sequences with numbers too, like our multiples, 2, 4, 6, 8, 10. They're a pattern of numbers. They're in a certain order. Term is each number that's in that sequence, and it could be the first term, the starting one, the second, third, fourth, and when we get to a whole bunch of terms, we just call it the nth term. I don't think we're going to be seeing an nth term in our lesson at school, but at some point, if you continue with math, you will. Now, when you're asked to determine the pattern or to make a number pattern, there are some steps that we have. And this will make sense when we see our problem. The first is underlining the starting number, circling the rule, box the number of terms needed, complete the pattern, identify features of the pattern. This will make sense when you see the question. Let me move this down just a little bit. Okay, so here's our instructions. Here's our problem. Starting with 21, create a pattern that increases each term by 2. Stop when you have 7 terms. Okay, this is where it'll start to make sense. And don't worry if it doesn't make sense right away. Math is like that. You have to do it a lot, and then it will start making sense. Let's look at our steps. Underline the starting number. Starting with 21. 21 is our starting number. Create a pattern that increases each term by 2. That's the rule. The rule is that each number in the pattern, each term, is going to be increased. So if I were going to describe that without words, I would go increase by 2. Or I could do plus 2. Stop when you have 7 terms. Box the number of terms needed. We need 7 terms. Complete the pattern. We'll talk about identifying features of the pattern in a moment. So we're going to start with the number 21. So we're going to stop when you have 7 terms. Does that mean 7 terms altogether or 7 terms after the 21? I'm going to go after the 21 just in case. So 1, 2, 3, 4, 5, 6, 7. Okay. So I'm going to need to fill in 7 terms. Starting with 21, my rule is that I'm going to increase each term by 2. Increase, that's a fancy way of saying add 2. So what is 21 plus 2? I can put a little plus 2 up here. 21 plus 2 is 23. 23 plus 2 is 25. 25 plus 2, 27. I'm going to add 2. 27 plus 2 is 29. 29 plus 2, 29, 30, 31. 31 plus 2, and I can always use my fingers, 31, 32, 33. And 33 plus 2 is 35. I now have a sequence. They're all in an order. I've added 2. I like the plus 2. This is also acceptable. And we've added 7 terms. The first term is 21, the second term 23, the third term 25. So we completed the pattern. Let's look at some features of the pattern. Do you notice anything interesting about this pattern? I've noticed one thing. Maybe there's more things. I don't have an answer key here, so but what I notice is that I notice something about the ending digits. 1, 3, 5, 7, 9. 1, 3, 5. I bet if we were to continue, this would end in a 7, and that would end in a 9. What do we call numbers that end in 1, 3, 5, 7, 9? They are all odd numbers. That's the feature that I notice. And as odd numbers, they can't be divided in half. Even numbers can. Odd numbers cannot. You cannot divide 21 in half. You have 10 and 10, 1 left over. For 23, you have 11 and 11, 1 left over. For 25, 12 and 12, 1 left over. So there you have this type of number pattern. Let's try one more. The instructions say to create a pattern that starts at 56 and decreases each term by 5. Stop when you have 7 terms. Okay, underline the starting number. Create a pattern that starts at 56. Starts at 56. Circle the rule. Decreases each term by 5. That's the rule. I'm going to, so each term goes down by 5, or we could say subtract 5. Stop when you have 7 terms. Box the number of terms needed. We need 7 terms. Okay, our starting number is 56. So 56. 1, 2, 3, 4, 5, 6, 7. Almost didn't fit that in. Okay, so what am I going to do? I'm at 56. Decrease each term by 5. Subtract 5. 56 minus 5. 56 minus 5 is 51. 51 minus 5. You might have to think about that for a minute. 51 minus 5 is 46. 46 minus 5 is 41. 41 minus 5. I'm starting to notice something interesting already. 41 minus 5 is 36. 36 minus 5 is 31. 31 minus 5 is 26. And 26 minus 5 is 21. Let's look at the features of this pattern. What do you notice? I notice a couple features, a few of them. What do you see? I see that it goes even, odd, even, odd. And that continues even, odd, even, odd, even, odd, even, odd. So it's alternating. That's one feature. Another feature is that they either end in 6 and then 1, and then 6 and then 1, and then 6 and then 1. Do you notice that? 6, 1, 6, 1, 6, 1, 6, 1. That is very interesting. Another thing that's interesting is that if you skip a number, it subtracts 10. 56, 46, 36, 26, or 51, 41, 31, 21. That's very interesting, but I bet that's because 5 and 5 equals 10, and so you're making that jump 10 down. Patterns are very interesting, and one great way to look at math is that in math you are discovering patterns. We look for patterns in life. Our brain really likes to look for patterns, and math is a great place to do that, and I hope that you found this helpful.